asking questions. It's been very, very interesting. So a great start to the festival. So yeah, up on the screen there, you can see what we've got coming up tomorrow. And also don't forget, we've got a whole second weekend of activities next weekend. So it covers all sorts. So if you haven't booked on, do book on soon. Andy, my co-presenter, has already been for a 40-mile tandem ride with his daughter this morning. I think he deserves a round of applause. I've barely moved. We're just going to give everyone just a few more minutes just to get joined. Okay, and I'm going to suggest that it's time to start. So thank you all very much for giving up your lovely sunny Saturday afternoon to come and join us. So this session is about the climate science. So we hear about it in the media a huge amount, climate change, what's it really all about? We've got two presenters today, myself, Sarah McClelland, and also Andy Wilson. We are carbon literacy consultants. Which means that this is part of our day job, to try and engage people, to take action, to reduce their carbon footprint, but most importantly, to understand what climate change actually is and how it impacts us. To get started though, we do have some housekeeping questions. Sorry about that one. So next slide. And I will be saying next slide a lot through this, sorry. So yeah, so just a couple of things to bear in mind. Those little quiz boxes at the top, that's to remind me to ask you all, so everybody's going to be on mute, so if you can please use the question and answer button down the bottom of your screen. If you scroll around to the bottom, it should appear up, Q&A. Stick in any questions that you like. My daughter Katie is picking up on any of these questions and she'll ask them throughout the conference if we've got time, or we'll hold them all to the end. If you have any feedback at all, just put it into the chat. So you might have some suggestions of what you do, what you'd like to do. If you have any ideas that other people could use, put it in that chat function so we can share it. With regards to the questions, though, I do have to say, if we don't have time to answer them all today, the course that me and Andy normally run is normally a full day session, so we've squeezed it into an hour. So I speak fast, but not that fast. So if we don't have time for the questions, we'll send out a response to all of them by Monday at the latest. There will be some polls as well. Please do participate in them. And I should have said right at the start, the webinar is being recorded and it will be uploaded onto YouTube in the next few days. The picture of the swan there is just to say, I've never done an online polls and everything else before. So whilst we may appear to be like swans floating on the top, you can rest assured that me and Andy will be kicking our little legs away underneath the water. Okay, next slide. Right, so climate science. Oh, yeah, there we are. Climate science, global overheating. We really need to stop referring to climate change as being global warming. Global warming sounds quite nice, particularly in Manchester. It'd be nice to be 1 or 2 degrees warmer. You know, the ice cream men would definitely get much better revenue, wouldn't they? But actually, we're talking about global overheating. The 4 takeaways from today is that it's real. This is real. It is happening right now in front of our eyes. The cause is us, human beings. But the most important thing is there is hope. We can get this turned around if we take action today. Next slide. So where do we live? What's this place we call home? It really is the Goldilocks planet. Next slide. We live on this lovely big blue marble. It is just in the right, it's in the sweet spot across this whole universe where we've identified billions of planets, billions of stars, and yet there's only one which has got all the perfect ingredients for life. So next slide. We have got an atmosphere which has got just the right amount of oxygen, just the right amount of carbon dioxide, just, oh, we've skipped a slide. If you can go back one, there we are. It's not too hot, it's not too cold. We've got water. H2O is a marvelous thing, but most importantly, it's got a really complex web of organic and inorganic systems that work together to give us this planet that we all know and love. But the future stability of our climate, of our ecosystems, is not guaranteed. We are now having such an impact that we are changing the climate and the weather forever. We need to take action today. I'm now going to hand you over to Andy, who's just going to do a quick time snapshot of the planet.
Thank you, Sarah. So yes, I don't know about the rest of you, but my head is quite frequently pickled with very large numbers, whether it's billions of years or gigatons or trillions of tons. So it's helped me a lot to scale things back. If we think about our world, rather than the 4.6 billion euro planet that it is, if we scaled it back to 46 years old, which isn't too far away from my current age, it's quite frightening, we could describe it as 46 years old, in which case the planet started producing fossil fuels aged 10. If we fast forwarded, so if we can bring up the next bullet point, if we fast forwarded to today, another 36 years, us as a species, humankind, arrived just 4 hours ago, just to give you a sense of scale. And we can have the next bullet point. We started guzzling fossil fuels just 1 minute ago. And never mind carbon budgets or any of the other rationing measures that we might take. If we were to go at the rate that we're going just now, we will consume all fossil fuels within the next 15 seconds. So it's fairly sobering. If we can have the next slide, please. And it's not just about fossil fuels as well. When we consider the wider carbon emissions, we can also use the same analogy of a 46-year-old planet to think about the world's forests. So within the last minute, of course, since the Industrial Revolution started, we have destroyed more than 50% of the world's forests. Clearly, it's not sustainable the way that things are going. Next slide, please. So some of you might be thinking that it's perhaps a little bit insensitive, banging on about climate change and the action that we can take in the midst of a global pandemic. But it's often overlooked that the story of climate change is also part of the story of coronavirus. The two are very much linked together. One impacts the other and vice versa. If we think about the activities that we have, the burning of fossil fuels, the consequences of these activities, we are eliminating several species every day. We are shrinking gene pools and the diversity of species so that there's much more in the way of disease. Disease essentially isn't controlled the way that it would be. And with the human impacts that we're having, it's causing species to flee from certain parts of the world to others where they can continue to thrive or try to thrive. And that's opening up much more in the way of animal to human interactions and human to human interactions as well. And when we think about climate change and the consequences of climate change as well, we think about water and food shortages. We think about mass migration as well, often with limited healthcare, and all of these things make it a lot easier for the transfer of pathogens. So climate change is making it much more likely for global pandemics to happen in the future. But there is good news as well. I know I'm painting a very bleak picture. When we think about the measures that we take within a global pandemic, such as coronavirus, we can it almost gives us a taster and a sense of the kind of things that we could anticipate within a carbon zero world. So if we think back to the first few months, as challenging as they were and as stressful with all kinds of implications, it gave us a little bit of a taste as well of what life might be like with quieter roads, with cleaner air, with greener areas, with more connected people, with better transport, more sustainable, active ways of living and moving around. So the action that we take when we think about climate change has a whole swathe of additional benefits that are attached to that. And that's very much the message of our carbon literacy course when we deliver that, that there are so many different angles of the actions that we take that will impact on us in a really, really positive way. And depending on who you are and what you're motivated by, we might frame that around financial savings, or we might frame that around improved health and quality of life and better transport, saving time. The list goes on and on and on. But that's part of what the message of climate change action and carbon literacy is all about. If we can have the next slide, please. I think we might have skipped a slide, possibly not. Back to the here and now. Of course, we are living in a world which is heating up very quickly. So we often describe that, the process as the greenhouse effect. Not all of you will have a greenhouse, but I suspect that quite a few of you will have a car, in which case you could maybe think about how uncomfortable it is on the few days of very hot weather, on the classic summer days that we have, when the car is left outside for a long period of time and we get into the car, and of course we're hit by that wave of extreme heat. But unlike a car, of course, on a global scale, we don't have the option of rolling down a window. We certainly can't press a button to get the air conditioning flowing. We are very much lacking in control that way to this greenhouse effect. So what that is essentially is radiation, solar radiation, as infrared radiation that passes through the atmosphere of the Earth. Much of the radiation is reflected immediately out into space, which is fine. A lot of the radiation is absorbed and then reflected back out from the surface of the Earth out towards the atmosphere. If it wasn't for greenhouse gases that we're going to be looking at in a second, much of that heat would pass straight back out to space. But because we have these greenhouse gases or heat trapping gases, a lot of that heat that would otherwise escape is held essentially within the atmosphere, and that is essentially what's causing the greenhouse effects. Now, don't get me wrong, I'm not going to criticize the greenhouse effect too much, because we need a certain amount of that. If we didn't have any greenhouse effect, we would be living on a giant snowball, which would be less than pleasant. So there needs to be a little bit of a balance. What we're seeing as a result of man's activities is because of the overabundance of greenhouse gases, there is too much heat that's being trapped. So rather than maintaining a safe amount of heat that allows us to thrive and other species to live on this planet, the amount of heat that's been retained is slowly building up, and that is what is ultimately causing our planet to heat up as well. If we can have the next slide. So when we talk about greenhouse gases, you'll often hear mention of carbon, and carbon might seem like the vilified greenhouse gas because we refer to a lot of things in carbon terms. But there are, as we're going to see quite shortly, a lot of other greenhouse gases, all of which are actually much more potent, like for like in similar amounts. But when we look at the natural flow of carbon, carbon emissions, there are huge volumes of carbon emissions, carbon dioxide that are shifted from various parts of the atmosphere into the soil, into the oceans, and back out again. So this picture here represents the flux of carbon dioxide and some of the different cycles that we have, much of which is completely natural. So without going into too much detail, the figures that you see on this infographic, they represent billions of tons of carbon dioxide. And the yellow figures represent the flux, the natural flux of carbon dioxide, whether it's been released to the air or absorbed in the soil or in the oceans. And the red figures and the text represent the additional carbon dioxide and emissions that are being released because of human activity, whether that's fossil fuels, which is the majority of the carbon emissions, and whether it's cement, deforestation, other kinds of land use change. So we have a lot of capacity on this planet. It's a very flexible planet, but it can only absorb so much of the additional carbon emissions that are being produced. The amount of additional carbon emissions that we are producing is far too much for all of these natural sinks, if you like, to absorb. So what we're seeing is additional atmospheric carbon that's been added every year, which is essentially driving the greenhouse effect and increasing the temperature. So if we can have the next slide, please. These are the greenhouse gases. So some of you might be surprised to see water vapor up there. It is technically a greenhouse gas. It doesn't absorb, it doesn't retain too much heat. And the effect is fairly modest, so it's not as potent as the others. But we still have to put it up there because it still has some effect. Because it's part of the natural cycles when we think about the oceans and evaporation, condensation, we don't want to give it too much grief. So we don't spend too much time thinking about it. But of course, we have carbon dioxide, or CO2. We have methane, which is another greenhouse gas. And we've got nitrous oxide and the fluorinated gases, which cover a lot of other specific chemicals, but they're now grouped within the greenhouse gas protocol. They're all grouped within fluorinated gases. So I've been prattling on far too much. I think it's time for a bit of interaction. So we're going to have a bit of a quiz through the wonders of Zoom technology here, through the poll functionality. So there's going to be 4 questions that appear on the screen, one at a time. And this is all about what your instincts are around greenhouse gases. So when we think about different activities or different things that have carbon emissions, carbon dioxide equivalent emissions, we might think about certain gases that are attributed more than others. So what I want you to do is to pick the gas that you think best matches the activity. So in this case, the first question, we're looking at a fridge. So which is going to be the culprit, the main culprit greenhouse gas that's associated with a fridge? So we've got carbon dioxide, methane, nitrous oxide, or fluorinated gases. So once all the answers come in, we'll see what the consensus is. I will reveal the answer.
Okay, I've had about half of you vote now. The vote's coming in.
That's great.
We're going to close it in 10 seconds.
Yep, don't overthink this one. Go with your instinct. We're not gonna tease anybody for wrong answers. There's no such thing as wrong answers in today's session. Right, very interesting. So we have actually the majority of the responses have come in under fluorinated gases, which I can say, I'm not going to do a drum roll, but that is the correct answer. So well done everybody that has gone for fluorinated gases. So yes, when we think about fridges, the gases that perform the function that you would expect within a fridge, cooling things down, are the refrigerant gases. So essentially the HFCs, hydrofluorocarbons that have that function. So moving on to the next question, we've got an erupting volcano. So obviously not specifically a man-driven activity or human-induced activity, but what gas would you associate and connect with a volcano? Which would be the main gas that you would associate with that activity? So again, I think it's the same options: carbon dioxide, methane, nitrous oxide, or fluorinated gases.
Okay, just going to give you a couple more seconds to get your votes in, and we'll end the poll.
Okay. Let's see how you've done with this one. Fantastic. Oh, that's quite an interesting result there. Split neck and neck with carbon dioxide and methane. So that's quite interesting. I'm going to give you the benefit of the doubt in assuming that carbon dioxide just nudges it past. Carbon dioxide is the main gas that's associated. This is one that often throws a lot of people. When we ran this activity, we used to have one of the sulfuric gases, hydro. I'm going to try and say it, but I'm going to fail. We don't include that now, but we have it under the refrigerant gases, the fluorinated gases even. But the majority of emissions when we think about a volcano is CO2. Still very, very small in the grand scheme of things. Even in a year where there's a lot of volcanic activity, we're still only seeing 1% of carbon emissions that come from volcanoes. So if we can have the next question. And this one, we've got a cow. So Daisy, whatever you want to call her, or him, what is the gas, the greenhouse gas that we would connect with a cow? Again, carbon dioxide, methane, nitrous oxide, or fluorinated gases.
Okay, going to be 10 seconds more to get your votes in.
You're doing very well so far. I don't want to put any pressure on you though by complimenting you too much, but the results that have been coming in are quite impressive. And look at that, 100% of you identifying methane, which is of course the correct answer. We have certainly never seen, in the equivalent activity that we run in carbon literacy sessions, we've never seen 100% of people opted for methane. So that is quite impressive. A bit of a fun fact, you're probably all imagining the creation or the emissions of that methane coming from a certain part of the anatomy, but not a lot of people realize that that methane is in fact, for the most part, belched out or burped out by the other end that you would expect. And this is one of the features of ruminants, of lambs, of cows, which accounts for the high carbon costing when we look at livestock farming. So that's one of the main reasons, in addition to the wider aspects of livestock farming, often involving a lot of fertilizers and nitrate-based chemicals that release a lot of nitrous oxide. So without further ado, I think we're on to the last question. So we have here a pre-2002 Nike Air trainer, which might seem like a bit of a curveball. It is probably the trickiest question, so don't sweat this one too much. I will reveal why 2002 is a relevant year. We're not just being pedantic. There is some relevance there, but again, the same answers. If you can select which one you think is the relevant gas associated with a pre-2002 Nike Air trainer.
10 more seconds to vote. I think people need a bit more thinking time for this one.
It's a tricky one for sure, yeah. This isn't one that that features in a lot of conversations around classic carbon emissions. But we have, again, a mix of answers there. I can reveal, we'd certainly saved the trickiest question till last. It is actually the fluorinated gases. It's one of the fluorinated gases that I can't actually pronounce just now. I'm going to follow this up in the chat. My mind has gone blank for naming this particular chemical, but the relevance of 2002 is prior to that year, the manufacturing process involved the injecting of this particular fluorinated gas into the unique selling point of the Nike Air trainers. I don't know if anybody ever owned a pair of Nike Air trainers. You'll now be frantically thinking if it was before 2002 or not. But before 2002, it was one of these fluorinated gases, which we'll soon see has several times more the potency of carbon dioxide. And what they realized soon after they identified that they'd have to change their ways, when they toted up some of the calculations for how many pairs of trainers they were manufacturing every year, they realized that by changing this part of the manufacturing process and substituting this culprit of a gas with something else that was inert, that didn't have that impact, it was the equivalent of taking 1 million cars off the road. So since 2002, the carbon footprint of Nike for this particular trainer, anyway, has been substantially reduced. So tiny little bubbles, quite surprising. But when we will look at the potency of some of the different greenhouse gases, and hopefully that'll bring to light just why that impact, that change that they made had such a difference. So thank you very much, everybody, for taking part in that. We're going to move on to the next part of the presentation. So if you can bring that up, brilliant. So this is the table. Apologies for the shade of green of this. Hopefully it doesn't offend too many pairs of eyes here. But we've got, again, down the left-hand column here, we've got different greenhouse gases. And what this table presents is the potency, the heat trapping potency of these various greenhouse gases. We don't need to drill too much into the figures, but if we took perhaps one of the middle columns, so for example, 100 years of any one of these gases in the atmosphere, then you can see different figures next to each of these gases. And what might be surprising is that next to carbon dioxide, it's only got a global warming potential, which is what the official term is for its heat trapping qualities. It's only got a global warming potential of 1. And for the amount that we reference carbon dioxide, carbon emission equivalents, you might be wondering whether we've got the order of this right. But we'll come back to that in just a second. Methane, you can see straight away as 25 times the potency of carbon dioxide. Again, looking at that 100-year duration. Nitrous oxide, almost 300 times the potency. And then it starts getting silly when we look at some of the fluorinated gases. CFC 12, it gets into the tens of thousands. I confess I had a complete mind blank before. Apologies for that. The specific gas within the fluorinated gases that I couldn't bring to mind involved with the Nike Air trainer pre-2002 was sulfur hexafluoride. I should have skipped on a couple of slides at that point. And with that, it's 22,000, almost 23,000 times that of carbon dioxide, which perhaps makes you realize why it was such a huge impact for the Nike Air trainer. So all these different values for different longevities, I suppose, different durations within the atmosphere. If we go to the next slide just now, The reason why we don't refer to the training that we do, Sarah mentioned before, carbon literacy, why we don't refer to that as sulfur hexafluoride literacy is because simply of the abundance of carbon dioxide, vastly more significant, the volumes of carbon dioxide in the atmosphere than any of the other greenhouse gases. So this is quite a simple infographic here that summarizes that. When we look at the heat trapping contributions, heat from each of the other gases, you can see that they're contained to fairly small boxes at the bottom of that chart. When we think about the contribution from carbon dioxide as a greenhouse gas, it takes up the vast majority of the space there. So you can see straight away most of carbon equivalent impacts is from fossil fuel derived CO2, whether that's coal, gas or oil. In the right hand section of that, you've got other sources of CO2 as well, deforestation, cement process emissions as well, and other industrial process emissions. It's probably just as well that we didn't have any of these other greenhouse gases in similar volumes to carbon dioxide, because if that was the case, as we saw with the previous chart, then we'd be in an even worse and even more urgent crisis than we already are, which is clearly enough. So if we can go to the next chart. And this one here, this chart we use in quite a few of the sessions just to give a bit of a snapshot of the trends in carbon emissions, carbon dioxide concentration over the last few hundreds of thousands of years, as well as temperature. And you might be wondering, how do we know anything about carbon dioxide concentration more than the last few decades, or temperature for that matter? And that would be a good question. So we have lots of very accurate means of recording carbon emissions and temperature, tens of thousands of recording devices all over the world, from weather stations, satellites, buoys, ships, and all of these provide very precise figures. So you can see in the middle of this chart, it says year before present, present being 1950. From 1950 onwards, we've had all these very specific, very precise means of recording. And prior to that, we've had to make use of something called proxy data, which is the data that we can glean from the natural evidence that we have around us, whether that's from tree rings, from cave sediments, ocean deposits, from pollen, or from, in this case, from an ice core, from a Russian ice core, no less. So the way that that's given us this information is that it's almost like a time capsule. If you can imagine this massive ice core that goes down hundreds of meters through the ground, is extracted, and at different depths of the ice core, it gives us an indication of carbon dioxide concentration and temperature at those different depths, representing different points in time. And they can very accurately deduce from those different depths what period of time it is that relates to. And the way that they can get carbon dioxide concentration is because at those different depths, they extract little samples of the ice, which contains bubbles of air, which are essentially samples of the atmosphere at that time. So they can take a direct measurement of the carbon dioxide from these bubbles. With temperature, it's a little bit more complicated, but it's to do with a particular type of oxygen atom called an isotope. And it's the ratio of these isotopes that indicate for these different times what the temperature would have been at the time. So that's enough background really for these charts, but you can see that there's peaks and troughs across those hundreds of thousands of years, and these are the natural trends that we see you can also see there's a lot of interplay between these two charts. So we can see that the concentration, the carbon dioxide concentration, will dip down to about 200 parts per million, and then it will increase many tens of thousands of years later to about 300 at the tallest peaks. And we can see what the knock-on impact that has on temperature as well. So there's a very close interplay. And if you can bring it on to the next part of the slide, please, Suze. So this shows us, it's a little illustration of what the world would have looked like in the middle of the last ice age, which was roughly began 70,000 years ago and ended 10,000 years ago. And the ending of that ice age took about 4,000 years, over which the duration, the temperature increased about 3.5 degrees. And that came from a difference in concentration of about 100 parts per million of carbon dioxide. So that 100 parts per million increase in carbon dioxide is connected to the increase in temperature of 3.5 degrees, but that's over 4,000 years. So the reason that we're concerned, the reason why this is a crisis, is because we've seen that increase in 100 parts per million added on top of that again, but it's only been in the last few decades, the last 100 years, since the Industrial Revolution, a tiny, tiny splice and slither of time that we've seen more than 100 parts per million. We're now at 411 parts per million in carbon dioxide concentration. So knowing the direct interplay between carbon dioxide concentration and temperature, it gives us some reasonable cause for concern. Can we go to the next slide, please, Suze? So I'm going to hand back over to Sarah, who's going to tell us a little bit about the indicators of a warming world.
Thank you, Andy. We had some great little questions which I was able to rapidly type a response to there in the Q&A. So please do keep your questions coming through. Looking at the time, we're not going to have time for verbal responses to questions. So do stick them through on the chat. Me and Andy will do responses as quickly as we can rather than have to do Q&A at the end, if that's okay. So Andy's covered that the atmosphere is we're releasing more and more greenhouse gases into the atmosphere. What is the impact on us? And what we know is, and what we've known since the 1850s, John Tyndall identified this in the 1850s, we know if we release CO2, or sorry, we know that CO2 has got this global warming, it's got a warming potential, and therefore it's going to have an impact on our greenhouse gas, or sorry, on our total temperature. And therefore, what are the indicators? What do we see then as these indicators of a warming world? How do we know that it's real? So these are just a snapshot of some of the things that we've seen in a generation. So as the world gets warmer, our waters, our oceans, our seas actually retain heat better than land. So they're getting warmer. And of course, that means they release humidity. So you can see right at the top of the chart there, humidity. So one of the issues with higher humidity is literally what goes up must come down. And as we all know, we live in Manchester, we've got a few hills around us. So those clouds hit those, fill up the water onto us in great big dollops. Do you remember in the good old days, we used to get rain when it was spitting? Now we only ever seem to get intense rainfall, and that's partly because of the increased humidity in the atmosphere. Other things that we've seen is the glaciers melting. We'll talk more about them in a minute, but also the spring coming earlier. So I planted an apple tree when I first moved to Manchester. I used to get the apples the start of September. Now those apples are in fruit much earlier. So we've already had all the apples off the tree now. And that's quite phenomenal, isn't it? So that's only in the 15 years since I've moved to Manchester, we've seen that change of season. So spring coming much earlier, and that has a knock-on effect. We've seen sea level rise. We're seeing this in so many cities that are at risk of sea level rise. So even the UK, because often we think about that global warming is impacting other nations, London is a very, very flat city and it's at sea level effectively. And so already they're starting to identify that London is one of the cities at risk of sea level rise. And so they think by 2050, it's going to start being impacted. The Thames Barrier can only keep back so much water. What else have we seen? Of course, we've seen the tree lines moving poleward and upward, so moving into more further higher up the mountain ranges than previously, and that's having an impact on species as well. Next slide, please. It will come in just a second. I think my internet connection, I hate to say it, is slightly delayed. So there's lots of data. So it's not just what we're seeing with our eyes as we go through life, but there's loads and loads of data which supports that we are seeing an increased increased temperature across the globe. And these are just some of these things that have been identified. And these are all the indicators that the world is warming up. So this is from the US. But we can equally get this data from the Met Office, from the Chinese equivalent. So everywhere across the world are seeing these same indicators of a warming world. Next slide. There will be a next slide any second. I've got a feeling my internet is just really, really slow. So how does this impact us then? So sea level rise, all the rest of it, how does it actually impact us? And it impacts us by the number of natural loss events across the world. So this graph was actually done by Munich Re, the insurers, because of course the insurance industry is really worried about climate change and global warming because it impacts their bottom line. And as you can see, so this graph just goes back over the last 30 years, 40 years now, back to 1980. And as you can see, across the globe, worldwide events, we had less than 300 typically. Still not pleasant if you were in one of those 300, but less than 300 typically. By 2018, we're hitting over 800 natural loss events. So that's where things like wildfires, which are now increasingly common, things like drought, extreme drought, and flooding. So you can see across the bottom there, it gives the color coding. So red is geophysical, the green then is meteorological, blue, of course, the water, hydrological events, and then the orange at the top, that's climate one. So that's things like fire and drought. But as you can see, every single one is increasing. Next slide, please. So across the UK, are we seeing those changes? Yes, we are. So the Met Office does the annual temperature check for us. And this goes back to 1884, so roughly the Industrial Revolution. And each of these colours represents whether it's warmer or colder than the average across that time period. And you can see that the warmest 5 years up until 2020 were all in the 20s. The year 2000 onwards, yeah. So we are seeing this real increase in significantly higher temperatures, not just in the UK, but also across the rest of the world. Next slide, please. So how are we seeing that at home then? This was one of the fires on Saddleworth Moor in the summer of 2018. That was horrific. I don't know about you lot, but in my office in Didsbury, we could smell the smoke all that far away. The fires there are very, very difficult. If we could do the next slide as well, please. Very hard to put out because it's peat, which means it can burn underground and then pop up somewhere new. So really, really hard to treat. It's one of those things, like if you think about the firefighters having to put that out, having to traipse across the Saddleworth Moor with all the kit, unable to get the engines anywhere nearby, it's very, very difficult. The fires are getting more intense in the UK and elsewhere because we're not getting the predictability of rainfall that we used to get. So we're getting higher temperatures, warmer summers, and less rainfall, less periods of rain, which means then that the ground is drier and it's like a little tinderbox ready to light. Next slide, please. But we're also seeing that change across the globe as well. So this is this picture top right is Sydney, Australia. So they managed to achieve a top temperature, which is rather sad for them, of 50 degrees in June 2018. sorry, in the summer of 2018 for them, and that's just not habitable. Australia is, you know, it's always been hot, but they've always had lovely cooler regions around by the coast. That's where most people live. But in Sydney, Australia, it was just getting too hot, and people were having to move because their homes were not ready for that level of temperature. They could not live with it. Next slide, please. We've also seen it then, she said, I'm not quite too sure what's coming up next. Oh, yeah, right now, San Francisco. The Californian wildfires are the worst they have ever seen. So 2018 was the last worst on record Californian wildfires. This year, they've burnt through 4.5 million acres, which is an area slightly smaller than Wales. Tens of thousands of people have had to be evacuated. I don't know the latest figures on how many have been killed. But can you imagine, going back to Andy's point earlier, having to cope through the COVID crisis and be evacuated from your house because there's a fire raging? The impacts as well, so you're having to breathe, you're having to use the masks for COVID, plus you're having to breathe in all that polluted air from the forest fires. Now, don't get me wrong, it is partly, and you'll hear lots from some politicians, one whose name begins with T, but it springs to mind, in which he complains it's because the forests haven't been managed properly. There is a teeny tiny bit of that, teeny tiny bit. The biggest impact, though, is that they've gone through a drought, a record drought for the last 10 years, which means that over the last 10 years, millions of trees have died just because of drought conditions. And that means that they are ready, they are perfect fuel for these fires, which are then just raging and spreading. So yeah, so whenever you hear in the media, it's about bad forest management. It's not true. It's the temperature and the fact that they are in drought conditions now. Next slide, please. Yeah, just another picture of the fire. Sorry, next one. We're hopefully then, oh yeah, here we are. So this is where I do a little bit of a personal story and say my great granny came from Saskatchewan. And this is in her lifespan. So this is the glacier, 1924, over a kilometre deep, came all the way down the valley. As you can see, 1985, same photograph, same location, middle picture there, significantly shrunk. 2011, it barely exists. We are seeing this in loads and loads of mountain ranges. So it's really bad for lots of reasons. One of these things is a tipping feedback loop or a tipping point in that lovely white snow reflects heat back up into the atmosphere. And so the more land we have, the more it absorbs the heat, which means global warming gets worse locally. But also those glaciers act as like a big water reservoir for cities downstream, for irrigation. And so one of the things we're already starting to see due to global warming is water scarcity. And there's one of the big concerns is who's going to start fighting over war. We're already having to have agreements across Europe. So Germany, for example, it's at the end of the Rhine. They're not getting as much water to the end of the river as they used to do, which means they're no longer able to use it as effectively as a transport network. So they used to put lots of ships up and down the Rhine. They're struggling because the water levels are so low because of the loss of snowmelt, because of the loss of glaciers upstream. Next slide, please. And locally, of course, Lime Park, one of my favourite places to go for a walk. Lovely cycle route there, which I can talk about tomorrow, but also really perfect train line. You can get straight on the train from Heatons Chapel up to Lime Park. It's lovely to go to. You don't need your car. Separately, mass floods. So we're seeing this impact even on our doorstep. Next slide, please. But of course, we've had rain before. We have had rain in Manchester. It's quite famous for its rain, although it doesn't rain as much as what people think it does. But now we're getting this intense, heavy rainfall. So I think this was something like we had a month's worth of rain in 24 hours, and that caused the floods. We shouldn't be getting that intense rainfall. Next slide, please. So yes, a disaster for the National Trust. They recovered from it really, really well. But in other areas then, one of the things we have to think about is this intense rainfall is how does our infrastructure cope? So things like telecoms, I do love this picture. Andy, this is from Perthshire, sorry to take you home, but it really does amplify it. So how does our telecom structure cope with all this flooding? We've got to think about how we're going to have to change and spend an awful lot of money changing our infrastructure to cope with climate change, or we can spend a bit of money to stop climate change happening and then not have to worry about our infrastructure. Next slide, please. We don't have it too badly. We have got the money. The National Trust has got the money and got loads of support from local people. You know, they had a flood fund, which lots of people put lots of money into, which is fantastic. This is in Jakarta, though. They don't have that wealth to be able to cope with climate change and be able to adapt and be able to recover from it. So Jakarta is sinking. It's sunk by, I think, something like 1.5 meters because they're having to absorb the, or sorry, they're using the groundwater as a water source. That means it's sinking, but on top of that, then they're having more intense periods of rainfall, and the water has got nowhere to go, which means it sits in the city and stagnates. They're already having to move Jakarta to another part. So the talk at the moment is in the rainforest, which is another disaster in itself, but they're having to move it. And there's hundreds of thousands of people simply cannot afford to cope with these levels of floods. Next slide, please. I'm loving this, Wayne. Oh. As you can see from the picture, we've got the lovely Arnold Schwarzenegger. So if the Terminator talks, we should listen, shouldn't we? He was governor of California, and this was his big thing. He was saying he doesn't want to be the last investor in Blockbuster as Netflix emerges. And he's seeing the fossil fuel industry as being exactly the same. He's saying, hang on a minute, that, you know, digging out dead dinosaurs, which is effectively what fossil fuels are, we should move on from that. We should be looking at renewables. We should be looking at reducing our space heating demand so we don't have to keep investing in fossil fuels. We should be looking at the future. So of course, with the Heatons Climate Action Festival, we'll be talking about e-cars. I think that's next Sunday. Have a look on the programme. But what is the future? What's that technology around the corner that we should be investing in rather than fossil fuels? Next slide, please. And then in Stockport, so Stockport Council very wisely had an independent company come in to assess their carbon footprint for them. So rather than go off and think, oh, we'll just do this, we'll just do that, that's going to reduce our carbon footprint, they actually had it independently assessed. And these are the big three sectors that Stockport needs to look at. So Stockport Council itself, its buildings, it's got a teeny tiny carbon footprint. So Stockport Council can only control a limited amount, but actually where the big impacts are transport. So I hate to say it, that's us. How are we getting around? Are we cycling? Are we walking? Are we using our cars? What sort of goods and services are we actually purchasing? Are we going for the Amazon 1 hour delivery, which comes in a very old van, or are we looking at more sustainable, going up to our local shops and using them instead? Industry and commercial. Stockport's got quite a lot of industry and commercial sectors, so they want to, as part of the Carbon Action Network, they want to improve what our businesses are doing. And there's a nice big orange chunk at the bottom. That's domestic. That's what are we as every individual in our households using in terms of our carbon footprint. Next slide, please. So what can we actually do? There's a limited amount. Because you sort of feel as an individual, there's only so much I can do. But the top thing you can do is look at your own carbon footprint. What can you do to reduce it? Next slide, please. The other thing you can do is push for change as well. And this is where we all have to become activists and work out what we need to do. So cutting your own carbon footprint, first thing you've got to do is calculate it. If you don't measure it, you can't change it. So what is it? So good and bad carbon calculators, sorry, really good carbon calculators are Hard, Bad, or Bananas. And the other one is the World Wildlife Fund. These links will be available on, I think we're going to send an email out afterwards so you can have a work through your carbon footprint now. Next slide, please. Andy, we've got 6 minutes. We're going to have to speak so fast. Go for it.
That's right,
over to Andy for working out carbon footprints.
So this is a, thanks for that, Sarah. This is a very little, a short taster, just to give you all some random activities and some items here, and the prospect of ordering them in terms of carbon emissions. So this really sits at the heart of carbon literacy. If we want to be able to reduce our carbon emissions and our impact, then we want to know what decisions that we can take in order to make the biggest difference. So in order to be able to identify the best decisions that are available to us, we need to know where we're starting. We need to know how much things cost, but in carbon costs. So we're going to do a very quick quiz, another poll, and I'm going to get you to order the 4 items that you saw there on the screen. So we've got 1 litre of water, in a plastic bottle. We've got an 8-ounce raw beef steak, a 250-gram pack of air-freighted asparagus, and a 300-gram portion of local seasonal carrots even. So the question is identifying which one you think has the largest carbon footprint. So I'll let you do that now.
Okay, a couple more seconds, then I'm going to close the vote.
That's great.
There we go, and I'll share the results.
Okay, so the majority of you have correctly identified the beef steak as having the highest carbon emissions. So I did reference before, rumination produces methane. Livestock farming has a number of different layers of carbon emissions related to it. Interestingly, carrots only at 84 grams there. Some of you might have thought that that would be a bit higher. They're probably one of the most efficient vegetables that we can grow. They can grow in natural conditions. They don't need anything extra. A bottle of water of 400 grams, but still 1,000 times more than water that you would get from the tap. So the key takeaway from this is if you're in a place where you can get safe water to drink from the tap, then do that. Rather than getting it from a bottle. All restaurants and pubs are legally bound to provide you tap water if you ask for it. So don't feel ashamed or embarrassed that way. I'll move this over here. Asparagus is surprisingly high as a carbon cost, 4.5 kilograms. But that is on the basis of it having been flown across from Peru because we've been purchasing it out of season. So there's a very narrow seasonal window that asparagus grows in May and June. If you get it outside of that window, chances are it will have flown from a very long way because it deteriorates quite quickly. It necessitates being flown. So it means that it's 5 times the carbon cost that it would be if we got it locally. Of course, the beefsteak is...
I call it a diva veg.
What was that, Sarah? Sorry? Oh, there's the lag.
Oh, sorry, I was rudely interrupting, and I said I call it a diva veg, a diva veg. Asparagus,
yes.
have it when it's in season, in June, July, August. But yeah, outside of that, it's a diva. Likes to go first class on those flights.
You can go to town and go out to town in May and June in asparagus, but beyond that, yeah, leave it well alone. And then the beefsteak, near enough 6 kilograms. So if we go on to the next one, so this represents food choices. And non-food items as well. That was the last one that we did. This represents, when we think of carbon footprints, there's 4 areas. Food, non-food item purchases, so clothing, the services we buy, gadgets, banking, pensions. So those 2 we covered in the last little poll that we did. And the other 2 main areas of a carbon footprint are represented here. These are 4 examples here. So travel and home are the 3rd and the 4th categories. So again, similarly, we've got a round trip from Hong Kong or from London to Hong Kong, economy class, an hour of web conference on an average laptop. You can use this as an example. A 10-mile congested car commute. So what would that be as a carbon cost? Where is that going to lie? And the last one is insulating a loft in an average 3-bedroom house. So which is going to be the highest carbon footprint for these? So if you can quickly whisk through those.
Okay, a couple more seconds and then we'll close the poll.
The moment of truth. And that's very impressive. Okay, so 85% of you have gone with the round trip London to Hong Kong, which is absolutely right. And then the others have gone for the second highest of those 4 activities. So if we go to the next screen, then we can see a little bit more detail on that. So 3.5 tons for that round trip. So that's economy class. And one of the things about flying as well is that the emissions are twice as high, or the effect of those emissions are twice as much, because if you think about the plane at a certain altitude, which you would hope it would be, it's directly emitting those carbon emissions into the atmosphere. And that causes twice of the heating effect. So 3.5 tons for that. The 10-minute congested commute, 16 kilograms. So that's a lot of carbon emissions racking up in those 10 minutes. And that's about 4 or 5 times more than the same journey that you would make, but if the roads were clearer. A 1-hour video call or web conference such as this is just a meager 10 grams. So I hope nobody comes away from this feeling guilty. In the grand scheme of things, relative to other activities, it's fairly modest. And the interesting one here is loft insulation. So although there's an outlay of 400 kilograms of carbon for insulating the average loft, in terms of payback, carbon payback, that happens within about 4 to 5 months. And then you're saving 1 ton of carbon dioxide thereafter. So that's an interesting little stat. So I'm going to hand back to Sarah for the last little bit in the last section of this.
Thanks, Andy. And I'm immediately going to say, next slide. So, pushing for change. This really is what the Sustainable Living in the Heatons Climate Action Festival is all about. It's saying we need to make a change. So one of the best things you can do is increase your knowledge, search out for information. We've put a little tag up there for the ethical consumer. One of the biggest things we can do is spend our pounds wisely. It's thinking about how can we get the best value in terms of reducing our carbon footprint for the pound we spend. Ethical consumers, brilliant at that. So it's thinking about, am I going to go to a big supermarket, or am I going to spend my money more locally and support the local economy? Am I going to fly to Barcelona for the weekend, or am I going to take the benefit of getting the train up to Edinburgh, for example? Much lower carbon footprint, but also it's a healthier way to be. The other thing we need you to do is chat to friends and family. Sometimes it can be a really hard conversation to have, but it is actually talking about, actually, you know what, I took the train to Edinburgh and had a really good time on the train, had a really good experience of it, was able to chill out, we played cards, we chatted. Whereas if you're in the car, you might get stuck in congestion, it's quite a miserable existence. And so for talk about how good it is, the positive benefits, you know, particularly using our green space as well. Speak to your company. Does your company have a sustainability policy? Are they doing sustainability actions? Are they seeking to reduce their carbon footprint too? You know, if you work for an organisation, you can turn it around from the inside. And of course, chat to our MPs and our councillors. They're the ones who can sort of, you know, they will take what we are saying, they'll listen to us, and they will make a change. But unless we ask for change, why would they change anything? You know, they really need to know that this is what the community wants. And of course, protest. This was mentioned quite a bit in the opening session with Andy Burnham and our councillors. Protesting is a very good way of getting that message out there that you want to see change. So become an activist, find out more about what's happening across the local area and take part. Final slide. We are asking for a massive, massive change, but you know, a bit of a revolution, but we've seen this before. On the picture on the left, this is the same road up into Times Square. And then you see on the picture on the left, 1903, every single one of those vehicles is a horse and carriage. If you'd have said to those people in 1903, in 10 years' time, this will all be cars, there'll be no horses and carriages left, they would say, what? They break down all the time. They're too expensive. You can't get petrol. There's no stations. You know, there's no garages anywhere. Nobody knows how to fix them. You know, they would have had all the same arguments that we're hearing today about climate change and about moving to alternative technologies. Ironically, in 1903, the car was seen as the solution to the environmental problem, which was, of course, horse poo in the streets. So we've gone from having that one problem to moving on to a different problem, but change has happened. In just 10 years, we went from horses and carriages across to cars. We'll be making the same change. We're asking for the same change in the future. Next slide. So I was going to say we don't have time for any questions, so apologies. We'll go through the questions which have been asked, and then we'll send an email out. So yeah, so the big message from today is the transition is taking place. You can help drive that transition by using your feet as such, by deciding what you're going to consume. Are you thinking about the company? Do they pay a living wage? Do they consider the carbon footprint, the environmental impacts of what they do? But also through your voice as a citizen, so speaking up to your MPs. We also have lots of ideas to make a difference. Please do join in on loads of events over this weekend and next weekend, and then talk to others. Yeah, share those ideas, join in and get involved. Okay, last slide, and that's us done. So thank you all very, very much for your time. Really, really appreciate it. If you have any questions or anything, do tweet us or send us a message, send us an email, give us a shout on Facebook. And I would just like to say thank you all very, very much. And I think I'm going on to plastics now and how to reduce my plastics. Looking forward to finding out more. Thank you.